Alright, good afternoon everyone. Welcome back to Remote and Flexible Learning 2.0. So, we're just going to do a quick catch up of what we did while I was in the meeting on Monday and you were in the class with Miss Findlay. And what you should have done was to fill out the table of values that I put up on the board and then sketch them, which is right here. Here is the board from the last week. So the table of values had four parabolas in it. The first one just being the most basic one of x squared. What you should have been able to do was to fill in the table of values. When you sketched it, it should have looked like this. In the graph on the left-hand side here, you can see these points here, which are the ones from our table of values. And you can see that that is the basic parabola. It's not a very good curve, but that's what it should have looked like. So that one should have been y equals x squared. All right. Now I'm going to move this up there for now. Actually, I'll move it over to here so we can still see the table of values. The next one you should have graphed was the one that says y equals negative x squared, which should have looked like this. And if you join up the points, it should have made a nice curve, which you can see opens out the other direction. All right, so this one is y equals negative x squared. All right, now the third parabola you should have graphed should have looked like this one, which looked weird because it was off to the side. But we can pretty clearly see that on the left-hand arm here, you've got a nice line of dots stopping there. Then if you continue that line of dots symmetrically up through that one, you'll see it would have looked something like so. All right, so this one would have been y equals x minus 2 squared. And the fourth one and last one you should have graphed should have looked like this. Which is this one. Just make it smaller. And you can see here that if you draw the line through the dots, it's been moved down. All right. So now our learning intention and success criteria for today are around identifying key features of those parabolas. All right. So now key features are parts that every parabola has that we're interested in. So you can see that parabolas being different from linear equations, this one has a section here where it comes up, then goes down, or it goes down, turns around and goes up. We call this point here the turning point. So turning point is where it changes direction. All right, so there's the turning point. Is where a parabola changes direction. All right. Now what we're interested about those is first of all being able to tell where it is and then being able to locate it with a point. So you can see this one here on the left hand side, its location is 0, 0. This one here at the top, its location is 0 on the x, minus 3 on the y. The one on the right-hand side, is still 0, 0 like the original one. And this one here at the bottom, its location is 2 on the x and 0 on the y. All right, so what you need to be able to do is look at a graph and tell me the location of the turning point. And you would label it like this, TP equals 2, 0, for example. All right, so that's the first key piece of information we're interested in. That is turning points. The next piece of information we're interested in from graphs of parabolas or graphs in general are x-intercepts. Now, if we look at these three here, you can see that it only touches the x-axis once. So there's only going to be one x-intercept. So we would list it like this, x-int equals, and you can see here that the x-intercept where it touches the x-axis is the same as the turning point, so we label it as a coordinate, like so. On the right-hand side, the x-intercept here we're interested in is equal to the same as the turning point again. We can look at the graph and see that it touches the x-axis just there. The one at the bottom, we can see that the x-intercept touches the x-axis at the point 2, 0. That's what we're interested in. And at the top here, you can see that this one is different from the other three. It has two x-intercepts. All right, so these x-intercepts are at, what is it at? It looks to be -1.5, comma 0, and 1.5, comma 0. All right, now if you look at the four x-intercepts, you might notice that the y value is always 0. So you can see there, oops, this one, that the y value in each case for the x-intercepts is 0. So in that case, it's not so important that we label it as a coordinate. What is important is that we get the x value correct, because that's the part that will change. Noticing this pattern will also allow us to find the x-intercepts when we're only given an equation and not a picture. So lock that away in your mind for later, but you just need to remember today that you're looking for two pieces of information so far, the turning point and the x-intercepts. All right. Now, the third piece of information I'm going to add to this from the graph that helps us tell parabolas apart is the y-intercept. And I'm going to focus on the bottom one for now because it has the most defined y-intercept. You can see that it goes through the y-axis there. So to label it, you would just write y-intercept equals, where is it? It's up at a height of 4. And the x value is 0. So to label it as a coordinate, you would write 0, 4. All right. The one on the left, to label it, you would look at this. You would say, where does it go through the y-axis? It goes through right here at 0. So the y-intercept is at 0, 0. The one on the right, you would do a similar process, and you would notice that it also goes through at 0, 0. And the one at the top, the y-intercept is down here at the level of -3 with an x value of 0. Remember, x always goes first. Okay, now notice that this y-intercept is the same as the turning point in the top case. It's also the same as the turning point in the one on the left and the one on the right, but it's different in the one on the bottom. Okay, so it's very important that you visually look at the graph and decide which key information am I looking for, where is it, then write its location. Don't always assume that it's going to be the same as one of the other pieces of information, because it does change. All right. So those three pieces of information, turning point, x-intercept, y-intercept, are things that allow us to tell parabolas apart from other parabolas and are really, really important pieces of information. The last piece of information we're going to look at for parabolas today is called the axis of symmetry. Now, the axis of symmetry sounds confusing, but isn't really. Now, if you were aware, in the table of values you did for the original one, you might have realized that when you filled in the numbers, you saw a pattern. All right, and that pattern should have been symmetrical. So if you look here at the numbers, you can see that it goes 16 outside, and then the next number in is 4, and then the next number is 1, and then a quarter, and then 16, and then 0. So it's symmetrical, and this 0 here is clearly the middle of the symmetry. All right, so in this case, 0 would be the axis of symmetry. So let's go and have a look at the original y equals x squared graph, which is this one here on the left, and you can see that pretty clearly that the arm on the right is the same as the arm on the left, just reflected across that way. All right, so this middle line here is called the axis of symmetry, where the two arms are the same on either side. You could not say that the axis of symmetry was here, because this part is not the same as everything on this side. The axis of symmetry has to split the parabola straight down the middle, like so. All right. So the axis of symmetry is the line which splits the parabola into two equal halves. All right, now that is going to be the thing that you look at every single time, just that definition to help you work out where the axis of symmetry is. So in this one here on the right hand side, you can see that this left half here and the right half there pretty clearly have an axis of symmetry down the middle there. And when I draw it on the graph, it's okay, but when I want to tell somebody where it is, I have to define that as an equation. So I would say the axis of symmetry is on the line where x always equals 0. And that means it could be anywhere along this y-axis, because it doesn't matter what height I go to, the x value hasn't moved away from the origin, so the x value is always 0. So the axis of symmetry is always defined as a vertical line, the equation of which is x equals something. All right, so the top one up here, again, you can see that the right-hand arm is there, the left-hand arm is there, and the axis of symmetry is pretty clearly still along that y-axis. So the axis of symmetry equals x, or is x equals 0. All right, so just to recap, the initial graph, the axis of symmetry was x equals 0. You can see there the two arms on either side are reflected across the y-axis. The second one, this one here, same again, hasn't shifted. The top one, same again, has only been moved down. So you can see the axis of symmetry is still there. But the bottom one is a different story. So if we look carefully at the bottom one, we can see that the turning point has been moved that direction, which means that the axis of symmetry, the two halves that I'm looking for, are now here and here. So the middle of them is pretty clearly right there where x equals 2. All right, so if we can remember that, the axis of symmetry is where the two halves are identical on both sides, and then write it as a vertical line equation, which is always x equals a number, we'll be able to work out where the axis of symmetry is for any parabola. All right, so to recap, the important information you need to be able to identify after today's lesson is, first one is turning point. Second one is x-intercepts. Third one is y-intercepts. And the fourth one is the axis of symmetry. If you can identify all of those four things off a graph by the end of today's lesson, consider yourself successful.